Hi, everyone. Welcome back. Today, I'm going to be talking about the situations from graphs and how we can describe them. So, let's read this example. Several students from the town of Mar travel by bike to the school outside of Fargo. Shown below are four graphs and stories. Which story goes with each graph? Okay, so let's read Maria's story, and these graphs are about distance versus time. Right? So before we even go get into the stories, let's talk about kind of what the graphs represent. Well, this means that over the first few minutes, they're traveling a distance. Then this person looks like they took a rest because time's passing, but they're not gaining any more distance to the school. And then they went at an even faster rate, right? They picked up and in less time did more distance, right? So just kind of looking at it that way is going to help us to know. So Maria says, I started to ride my bike to school. When I realized I left my lunch in my refrigerator, I went back home, picked up my lunch, and drove quickly to school. Okay, so with this one, I think it goes with graph 4, would be Maria's graph, and I'll explain why. Because it says she started out biking to school, and then she realized she forgot her lunch, so she went back, right? So she went backwards and ended up back, even though time has passed, back zero, the same distance as before from her home, right? With no distance gained because she went back home and then she quickly drove to school. So then here's the quickly driving to school part. Good. Okay. Dimitri, I was anxious to get to school early, so I drove very fast, but I hit a curb and bent the front wheels. Then I had to walk with my bike to school, but I was still on time for my first class. Okay, so this would be someone who at first really, went quickly to school, so not a lot of time passing, but a lot of distance, much like this, right? And then, walked slowly. So it took more time to cover just a little bit of distance at the end there. So I think Dimitri's graph would be this one. Okay. Then Chan says, I enjoyed my ride to school this morning and was taking my time, but then realized how late it was getting and I drove more quickly in order not to be late. Okay, so this is someone, it didn't say this person stopped exactly, but it did say they were taking their time, so driving slowly and then went more quickly. Okay, so I would say that is this one here because first they're driving slow and then in the end we see them pick up speed, right? We see the slope increase there. And so that suggests we're going more quickly at that point. Good. And then it says, write a story that Olga might have told using the information from the remaining graph. So this one would be Olga. And I guess we kind of already did that before, but basically, Olga, she drove to school at a fast pace. For the first part of the graph. Then she stopped to take a rest. So let's say she was very tired and took a rest. And then after she took the rest, she was rejuvenated and then she drove at an even faster pace. Very good. Awesome. All right. All right, so let's continue. This next example says draw an appropriate distance and time graph and speed time graph for the following situations. Okay. All right, so it says a car coming to a stop at a red light. So, what is our speed versus time? And what is our distance versus time? Okay, so the first one, a car coming to stop at a red light. Well, in that case, they're going to be traveling probably at a constant rate, and then they're going to realize, oh, there's a red light, and they're going to go slower and slower and slower, right? They're going to slow down near the end until they eventually stop and are gaining no more distance, right? Because they're stopping, right? Now that's their distance versus time. They're going to be traveling more distance in the beginning, and then as they're getting closer to the red light, they're going to travel less distance, even though the same time is still passing at a constant rate. They're slowing down, so there's less distance for the same time. What about speed versus time? Well, in that case, we're going to start here, let's say, right? Let's say they're starting at a good speed, and they're eventually going to get the speed down to zero. So the speed is going to be at a constant rate for a bit, right? Perhaps speed is at the same rate. And then the speed is going to gradually slow down, right? As the car is coming to stop at a red light. Because first they need to realize, oh, there's a red light, and then they're going to slow down and stop at the red light. Maybe not at an entirely constant rate, though, I guess. It could be even something like this would also work, because it's an exactly constant speed rate that they're slowing down, not necessarily. All right, the next one says a car is accelerating away from us. So the distance from us at first is very close, and then they're going faster and faster and faster away from us. So it would curve up like this, right? Because they're driving faster, 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 accelerating away from us. And same with their speed, right? Their speed would start slower and their speed would speed up as well. So the speed time graph would also look pretty similar as well. Because as their distance is increasing, their speed is, increasing as well because they're accelerating away, not just driving away from us at a constant rate. Then C says a car moving at the speed limit. So we don't know what the speed limit is, but the speed limit stays the same. So that would be driving at a constant speed throughout the time, not speeding up or slowing down. And then the distance here would be a line like this, right? Depending on the time, they're going at a proportional distance, right? With the same slope there. Good. Now, what about a car waiting for the light to turn green? Well, their distance would just be the same the whole time, right? Their time is passing and they're not making any distance at all. And same with speed. They're also not going any speed at all. The speed is going to be the same, and actually the speed wouldn't be here. The speed would be at zero. They're waiting for the light to turn green, so it would be like this, right? On here, where the time is passing and the speed is zero the entire time. The distance could technically be any certain place as long as the distance stays constant, then we're good. Okay. Example 3 says, which graphs below best display sales for each of the three items or services illustrated on this page? So the first one says records on sale, $10 each. Well, let's see. I think maybe this one would, because if it is one purchased, then it's $10. Two purchased would be 20, 3, 30, 4, 40, and 5.50. And also, you can't really buy half a record. You can't say, oh, I would like to buy 3.5 records, please. Well, no, they're not going to just cut up one of their records and sell it to you because no one would buy the other half, right? A half a record is worthless, right? So, therefore, I would say records on sale, $10 each, would best go with this one. What about the next one? It says clearance sale, all drapery fabric selling at $10 per meter. Okay, well, this one is also $10 per unit purchased, but this one we could have, halves and quarters, right? For example, 1.5 meters of fabric. Well, that extra half, that isn't worthless, right? That's still an extra part of our fabric that we might need. And so it's not worthless the same way that, cutting a record in half and selling someone half a record wouldn't make any sense. So with this one, I would say probably this one down here because it's the same as the graph up top, except we can do half units, right? Someone could buy half a meter of fabric, and that is still acceptable. Maybe they only need half a meter of fabric to accomplish what they need to accomplish. So that could work. All right. The next one says, enjoy your holiday. Rent a boat for $10 per hour. Okay. Well, let's see. The only difference between these two is this one, has this stair here where if you go up to 1 hour, then it's $10, which makes sense, right? If you do an hour or less, they'll charge you for an hour, right? If you do between 1 hour and 2 hours, they would charge you $20. If you do between 2 and 3 hours, they would charge you $30, and so on. Which, I mean, that's a pretty good deal to rent a boat for your holiday for only $10 an hour. But I guess that's not really the point of this, is it? However, this line doesn't really make a whole lot of sense. This extra space here, where it's 1 hour, would it be $10 or $20? It's kind of unclear. It could be anywhere from 10 to 20. And so that wouldn't make a lot of sense, right? Up to 1 hour should just be $10. And then 1 to 2 would be, 2 hours, and so on. So people aren't really going to rent a boat for like exactly 1 hour or exactly 2 hours, but they would just round up and say, okay, if it's more than 1 hour but less than two, then you're charged for 2 hours, right? If you went for 3.5 hours, well, then we would charge for 4 hours, kind of thing, right? So they're not going to charge exactly like on the unit, be like, oh, to the minute, okay, here's how much we charge you. No, it's going to be rounded to the nearest hour, most likely. And so I would say this one here, ooh, this one here is the best answer. Whereas this one here, it's a bit ambiguous, right? Is 1 hour going to cost $10 or 20 or 15 or, anything on this line? It's like, well, no, 1 hour should only be $10. Now, once you go above 1 hour, they'll start charging you for 2 hours. All right. If you do it for an hour and 45 minutes, they're going to charge you for two, right? That makes sense. But it wouldn't make sense to charge someone anywhere between $10 and $20 for 1 hour when it says rent a boat for $10 an hour. If it's exactly an hour, it needs to be just $10. Otherwise, they're not really doing what they said. Good. All right. Well, congratulations. That is it for Unit 1. I will see everybody back for Unit 2, and best of luck with your test. Bye, everyone.